Okay, Bismillahirrahmanirrahim. Dalam video ni, I just want to summarize the important equation for chapter 2. Yeah. So for the first things that we need to understand, first thing that we need to understand, we want to describe about about atom. Okay. Um, Atom and molecule. Okay, so by assume that the molecule behave like rebounding ball, physics are able to predict and explain some macroscopic phenomena such as the pressure when gas produce. But the model of pressure does not account or cannot explain the stability of the molecule. Did not account means that cannot explain the stability of the molecule. That could not explain the force that hold atom together. Yes. So diorang lama jugalah untuk realize, and then property of atom are molecule are not governed by the physical. So sekejap mana cerita dia mula ya. Then in 19th century, the young German chemist Max Planck analyzed the data on radiation emitted by solid heated solid element heated to various temperature. Then they discovered atom and molecule emits energy in certain discrete quantities or quanta, not continuous like white light, yang ada semua warna. Dia just ada certain warna sahaja. And the physicists assume that energy is continuous and any amount of energy could be released in a radiation process. Planck quantum theory turn physics upside down. Dia tolak, dia reject that this first theory yang dia assume energy is continuous tu. Planck discover new finding. The flurry of research has ensured altered our concept of nature forever. So they found that to understand the Planck quantum theory, first we need to understand about wave property, because in later on in the next subtopic we will look at the dual properties of atom. Okay, kita akan tengok. So first properties adalah dual tu means that two lah, dual wave property, and satu lagi Planck. Saya pun tak ingat dah apa ni, nanti kita akan tengok. Okay, so wave properties, tak ada apalah, itu kita dah tengok ya. Wave has length, height, and the number of wave that pass through a certain point in 1 second. So it has dia punya length is lambda, dia punya height is the amplitude. Lambda is the distance between identical point on successive wave. This is definition. This is definition. If you want to get the correct definition for lambda, this is the definition. This is the definition for frequency. Frequency, nu, we call it nu, is the number of waves that pass through a particular point in 1 second. This is nu. While amplitude is the vertical distance from the midline of a wave to the peak or through. So this is the definition for amplitude. You can look at this diagram to understand wavelength, amplitude, and frequency. Yang ini has more frequency compare to this one. Walaupun dia punya distance sama je kan, kat sini sama je jarak dia, tapi since wavelength yang ini lebih tinggi, jadi frekuensi dia rendah. Kalau yang ini wavelength dia rendah, frekuensi dia lagi banyak. Okay, frekuensi dia very higher. Okay, so that is properties of wave. From this property, the important equation that we need to know is this one. Yeah, but this is the speed of wave is equal to the product of wavelength. Okay, wavelength. This is wavelength and the frequency. But since we discuss about light, yeah, ataupun radiation, speed of light, okay, speed of light kita tukarkan, speed ni kita tukarkan kepada speed of light, which is 3 times 10 to the power 8, oh sorry, bukan negative 8 ya, 8 meter per second. Okay, 300 juta meter per second. Okay, you just imagine 300 juta meter. Sebenarnya you boleh guna either meter per second or kilometer. Yes, kalau you tukarkan kepada kilometer, dia akan berubah yang ni. So that one saya tak berapa ingat, kena buat conversion. Okay, 8 meter per second, kalau 6 kalau tak salah saya kilometer per second. Okay, so from this concept, okay, hertz semula ya, frekuensi kita dah tengok dari tu, saya tak nak discuss banyak. Okay, these are the equation that we get from this subtopic, or we also can change this ataupun we can write it in this form. Okay, C is equal to okay, sorry, bukan. Ya, salah. C is equal to mu times lambda. Okay, ikutlah apa yang dia nak minta. You arrange this equation. Depends on the question asked. Okay, then okay, saya tunjukkan yang ini. Yeah, this is important equation for chapter 2. So for wave properties, yang first ni, okay, wave properties, kita dapat this important equation. Okay, yang ini sahaja, yang first ni je. Ya, saya summarizekan. Okay, then further discussion of dual properties. Yeah.
Mama nak paper dulu. Kita.
Okay, dekat dalam bilik hijau dan bakul pergi ambil. Okay, so then we come with the Planck quantum theory, because in the Planck experiment, dia heat the solid element. Okay, solid hydrogen. Yeah, when solid are heat, they emit electromagnetic radiation over a wide range of the wavelength. Okay, so okay, this one, yeah. Okay, Planck solved the problem.
Mama ni phone nice. Mama.
Okay, sekejap ya. Planck solved the problem with assumption that depart drastically from the accepted concept. Yeah. Okay, classical physics theory, dia kata atom tu dia emit continuous radiation kan, tapi Planck said that atom and molecule emit discrete quantities of energy. Tak continuous. Remember between continuous dengan line, discrete means line lah. Okay, kalau continuous tu yang semua warna ada tu. Okay, so the energy of single quantum of the energy is given by this equation. Energy. So daripada mu tadi tu dalam wave property, dia relatekan frekuensi dengan energy. Dekat depan, dekat tempat mesin jahit. So dia datang pula dengan equation yang kedua ni. Energy for the radiation can be calculated using H time frequency of that radiation. So H is a Planck constant. This is the unit for Planck constant. 6.63 times 10 to the power negative 34 joule second. Okay, so be careful if you use speed of light in the unit of second, Planck constant pun mesti dalam unit second juga. Okay, so since mu is equal to C over lambda, jadi dia
kat mana?
Okay, jadi dia substitute mu with the C over lambda, then we get this equation. So this equation come out from the Planck theory. Okay, Planck theory. Okay, Planck theory dengan photoelectric effect theory lah Photoelectric effect theory ni is the one yang saya explain semalam tu kan, yang bila kita panaskan element, dia boleh emit radiation tu, and this is also okay, dia emit radiation tu. Then from that experiment we continue with the Bohr theory of the hydrogen atom. Okay, sekejap. Summarize of the equation for Planck quantum theory is this one, these two. Okay, yang ini Planck quantum theory equation. Okay, then the last, Bohr theory. Okay, so from that experiment also they found yang itu tadi dia belum lagi gunakan hydrogen atom elements tu. Bohr yang found that finding. So Bohr theory of a hydrogen atom, first to Einstein. Dia continue Einstein punya experiment. Then they found that when element is heat, the emission when element is heat, this one, when high voltage is applied between the fork, some of the sodium ion in the pickle are converted to sodium atom in excited state. So dia continue lagi dengan hydrogen pula. So that's why dia dapat the pink color, the pink light of the hydrogen. Bila didispersekan, actually it is not all the white component, white light component. It only has certain light, which is very discrete or line. So this line, the energy for this line can be calculated using Rydberg equation. Okay, so daripada eksperimen ni kita dapat equation this one. Okay, equation ni only for one orbital. This means that the energy for the electron that located or does not transfer or does not move, yeah, we can calculate using this equation. Okay, for example, because as I mentioned before in the class, each energy level has its own energy. Okay, for example, this one may be 1, this one may be 3, this one may be 6. Yeah, so how to calculate the energy for each level? We can use this equation. Okay, sebab sebenarnya macam kita lah ya, kita pun walaupun kita tak buat kerja, kita just duduk je, kita tetap menggunakan energy. So same with the electron, even though dia tak excited or go down to the lower energy level, doesn't move or doesn't delocalize, doesn't transition, doesn't happen the transition, does not transite, but it has the energy. So this is energy when the electron just stays still. Okay, but if we want to calculate the energy of the electron that jumps from one energy level into another energy level or go back to a higher energy level, we can use this equation. Okay, so this equation, dikombinkan equation, because we want to calculate the delta E ataupun the difference of energy, the changes of energy, E final minus E initial. So we arrange these two equation. Okay, we arrange these two equation, we get this equation. Okay, we get this equation. Okay, this one. And this equation combine with the Planck equation. Okay, you boleh tambah satu lagi dekat sini. This one sebenarnya sama juga dengan hash C over lambda. Okay, so this is the summary of equation for chapter 2. Okay, cuma saya nak saya pun tak sure ya, sebab tu masa saya mengajar tu saya macam pelik sikit, because actually Rydberg constant, ya, RH, the value of RH is this one. Ya, nanti saya confirmkan balik. Because dalam nota kita memang tak sama dengan this one. Ya? Sekejap saya tunjukkan. Okay, lain lah. Saya tak tahu mana satu yang betul. Okay, this is the one in the notes. Okay, saya pun tak apa. Sebab tu saya katakan memang saya tak suka sangat sebenarnya guna nota, sebab kita tak tahu kat mana dia refer unit ni. Ya. Tapi tak apa. You all tulis je mana-mana, since saya yang marking. It's okay. Dan yang ini pun kan saya tak jumpa reference, ya. Saya tak jumpa. Tapi sebenarnya tak ada masalah pun, sebab once you get energy, energy is equal to hash C over lambda kan. So nanti you bolehlah cari lambda ni. Okay, you can find the wavelength ni. Yeah. Okay. So saya tak nak guna nota tu. Saya back to my nota, this one. Okay, so that is the Rydberg equation. Yeah. Okay. Yes, this is all the same. We can try later on the exercise for this. Yeah. Okay, this one, the dual nature of electron. Yeah, itu yang saya kata tadi. Electron behave like wave. Yeah, and it also behave like stream of particle. Yeah, That's why stream of particle tu photon, dia ada mass semua tu ya. So these two lah dual properties ni 2, 1, 2. Okay. Saya rasa cukup sampai kat situ. Tapi sebelum tu, I just want to show you this summarize for the important equation of chapter 2. Okay, we have 1, sorry, 1, okay, we have 2, okay, and we have 3. Yeah, so this is all important equation for chapter 2. Yeah, okay, tak apa, nanti kita akan try exercise on each of these equation. Okay, thank you. Assalamualaikum.